Hello, everyone. Today, I'd like to talk about Declarative Cloud DB Service using Kubernetes. I would like to introduce myself. My name is Han Woo-hyung, and I am working as a DB as a service developer and operator in the cloud service team of Line Plus. This is the order of my talk. I would like to talk about what Declarative System is and why we developed DBaaS as a declarative system. And in order to implement a declarative DBaaS, what are some of the technical requirements? And then how the declarative DBaaS works. And then I will end my presentation. First, the what and why of a declarative system. In Line, DB is provided as a service so that developers can easily create and use databases. The types are MySQL, Redis, and Elasticsearch, and we plan to add other DBs such as MongoDB. And there are about 8,500 services on DB. And to enable these services, about 37,000 VMs are used, and they account for 35% of the total VMs used in Line. As you can see from the numbers within the line of services, we are using our DB. So it is our role to provide DB in a speedy and stable manner. But it requires a lot of operational cost to deliver so many DBs in a stable manner. And what gives us most headache is the VM failures. The more VMs you have, naturally, you have more VM failures. It's all related to software issues as well as hardware failures in hypervisor. So there are many reasons for VM failures. Of course, for general services, VM failures are taken for granted, but in DBaaS, it creates a lot higher operational cost. So in what sense, why does DBaaS require higher operational costs compared to general services? You have general web services on the left. In VM, the web server is activated, and the VM looks toward the remote DB. And as the VM web server, it approaches through a load balancer. And when there's a failure in VM, you can just create a new VM and launch a web server. The data is stored in a remote storage, so even with the new VM, you can use the data without additional work. On the right-hand side is where DB is deployed. The biggest difference is there are many DBs, and instead of the remote storage, they're using local storage for performance. And it makes it difficult to replace VMs. In order to replace VMs, you have to replicate a large amount of data. And different from the stateless web server, DB instance is stateful. So just creating the VMs and launching the DB instance will not be enough. You have to execute many commands for DB connection. So different from the web applications, DB requires a lot of work for VM replacement. As a result, as the scale of DBaaS grows, we had to come up with a new method. So the answer was declarative system. What is a declarative system and how is it different from the existing system? To understand better, maybe we should talk about imperative system first. I would like to use illustrations to compare imperative and declarative system. First of all, the manual driving is a type of imperative system. The driver will be so to drive, you are provided with commands like accelerate, decelerate, and shift directions. In order to get to the final destination, the driver makes decisions and executes commands. For example, the autonomous driving is the declarative system. In an autonomous driving system, instead of the user making decisions and executing commands, it just declares its final destination. then the system will do its best to reach the final destination by identifying the current location and what barriers there are. So it's a different system how to use from a user perspective. In an imperative system, in order to achieve the target, the user makes the decision and executes commands. But in a declarative system, the user just declares the goal and the system makes the decisions and achieves the goal. So the declarative system minimizes the user intervention or the manager intervention so that you reduce the number and amount of judgment, determination, and commands. So how do you make such a declarative system? The declarative system is not a new concept. It's about how you design from what perspective, so any tool can be made into a declarative system. But the method that we chose is to extend Kubernetes and create a declarative system. By setting it as a declarative system, Kubernetes is the open source platform for managing containerized workloads by declarative configuration. It started with container management, but it could be used as a declarative system using the custom controller. We used Kubernetes custom resource and custom controller to make the declarative DBaaS. But in Kubernetes, the container management function was not used, although it was quite useful. And the reason is as follows. First of all, the VM is used in line in a large scale. It has been proven for a long time, and it does work even in a large scale. So, with the VMs, many databases were created and were already being used. And without data migration, we wanted to integrate the DBs in a new DBaaS system. And the second reason was if we were to use the container as data plane, Kubernetes could become the single point of failure. The Kubernetes components they exist in multiple and they're redundant. But if there is a failure of core DNS or if the global setting is wrong, then it could create a failure for the whole cluster. DB has to be stable and reliable, and so the failure on the control plane should not affect the data plane. In order to solve this, we could implement multi-cluster, but it creates huge complexity, so we did not choose that option. And lastly, Kubernetes container management methods were not useful for DBaaS. For example, in pod, autoscaling is there, but DB instance is stateful, so it's difficult to use autoscaling, and pod scheduling had limitations when the local storage was used. Of course, in stateful set is provided to resolve this, but there were limitations to scalability to use all the functions in DBaaS. So we use the Kubernetes custom controller for the control plane, and we used VM for the data plane. I talked about the definition of declarative system and why we created a declarative system for the DBaaS. And now I'd like to talk about the technical details and considerations that went into making the declarative system. In order to make a declarative DBaaS system, what we did first was to manage the VM in a declarative way. In Kubernetes, pod is managed in a declarative manner through a process called kubelet. Likewise, in order to manage VM in a declarative manner, we made the Kubernetes custom resource that matched VM. There are 2 virtual cores, 8 GB memory, and DBaaS agent as a process. So that was the type of VM that we declared. In the VM custom resource, the VM operator monitors the custom resources and tries to satisfy the declared specifications. And as is declared, there is a VM created with 2 virtual cores and 8 GB memory, and inside, a DBaaS agent process is launched. But if there is a temporary failure in creating the VM and could not create the VM, the user declared the final spec of the VM, and the VM operator will continue to achieve this, and automatically the VM recreation will be repeated with the backoff. So we send commands for recreating the VM, and if there's a failure, another command could go, but this is a declarative system, so the VM will just declare the final specification and will be guaranteed that sometime a VM will be created. And the next thing that we did was to make the DB instance declarative. The white version, the white part of the slide is what I explained earlier. And let's just assume that the VM was created with this logic. First, we made the custom resource for one DB instance. Generally, through sharding or replication, the DB is activated with multiple processes, and inside we will call these processes DB instance. The DB instance custom resource is composed of parameters that DB process has. It's different for DB to DB, but for illustrative purposes, let's say the parameters are max client, limiting the maximum number of clients, and timeout, limiting the time. And so for VMCR, each node has a VM instance, and there's the custom resources, and it contains the DB instance setting. And the DB agent will observe the custom resource and try to reflect that in the local DB. And the DBaaS agent process is activated and is guaranteed by the VM operator, as I mentioned. And if that is the case, let's say the DB setting is to be changed, then what should we do? The declared DB specs should be changed. Let's say the limit time is changed from 5 seconds to 1 second. Then the DBaaS agent will find out that the declared spec and their DB setting is different, so that it will send the right command to the DB to satisfy the declared specifications. So compared to the imperative, what are some of the strengths that the declarative system has? Let's say for a reason you lose the DB setting within the VM. What happens? When the VM is deleted through the failure, or it could occur due to the user or the manager's fault. Then the DBaaS agent will notice the difference, and to satisfy the declared spec, the command will be sent to its DB. As a result, the DB is restored to the initial declared state. In a declarative system, the user will change the spec on purpose, and if there is a discrepancy, it will set it right, so it will make the total system robust. Up until now, I talked about one single VM and one DB instance within the VM and how they work. But we do use multiple VMs for sharding or replication purposes. In order to group the VMs, on the very top, we made the custom resource called DB Service. And the custom resource matches one-to-one to the DBs that are created by the DBaaS user. In this example, there are 3 VMs for making up the DB, and there's declaration for the VM and DB setting.
Then when the specification is declared, the DBaaS manager will observe, the components will observe and will create the necessary VM custom resources and the DB instance custom resources. And so because the DB services VM number is declared as 3 custom resources will be generated. DBaaS manager will only generate the VM or DB instance custom resource, and for the following operations, the VM operator and the DBaaS agent will be responsible for the operations. So to sum up, the user declares the DB service, and the DBaaS manager observes this resource and generates VM and DB instance custom resource. Each resource is handled by the VM operator and the DBaaS agent. So in this structure, for storing data or for asynchronous handling of DB, there is no message queue. Kubernetes is for distribution, or it is used as control plane. So the resource of Kubernetes is used for data storage and also for asynchronous handling of API server. Then what kind of impact will this structure have on Kubernetes? In this design, even if there are numerous VMs, will there still be no problem on the Kubernetes? Kubernetes is very expansive. It can expand very well, but it has a different usage pattern compared to general Kubernetes usage. So generally in Kubernetes, one type of custom resource is managed by one controller. But so even if there are 50 different types of custom resources, there are only 50 controllers in Kubernetes. But in this design, all VMs that make up the DB will have each controller. This is a drawing that shows the controller and the API server relationship. One DB service is made up of various VMs. And in a VM, there is one controller. So there are the same number of controllers as the VMs, and each controller will send orders to the Kubernetes API server, and it can create a lot of pressure on the API server. And so this kind of these controllers, how much pressure they have on the API, we wanted to know how this will work in this design. So we have run a short POC. So for the POC, we have set an expansion goal. Of course, large-scale systems are important, but if the system is too big, if there is a system down, there can be a massive data loss. So, and also the system can be too complex. Currently, for the bus at Line, there are about 37,000 VMs. So we created 2 Kubernetes clusters. 20,000 was our expansion goal. And also at the controller, we have performed very simple optimization. For instance, let's say there are 1,000 VMs, and if there are 1,000 VMs, we need 1,000 custom resources to respond to the VM. So within a VM, the agent will watch the custom resource. Generally, watch senses all of the changes in the custom resource. So one watch will be observing 1,000 resources. So the number of VM is 1,000, and for each VM, 1,000 resources are observed. So 1 million requests will be needed. However, the DBaaS agent does not have to watch all custom resources. It needs to watch only the DB instance that it is in charge of. So with the field selector, only one resource could be watched. But the field selector does not work within etcd, which is the storage of Kubernetes. At the API server, we bring all of the lists, and only the necessary parts from the memory will be sent back as response. So even if we perform this kind of optimization, the API server and DBaaS agent will have less pressure, but etcd and API server will not experience any reduction of weight. And after code analysis, we have identified that it is impossible to set field selectors based on etcd level. But we also identified that the resources are managed separately, and we can make a big volume of namespace. So the namespace The logical namespace is where the DB service is generated. And if we control the number of DB services that could be generated in the user namespace, we could reduce the watch of the custom resources. So for instance, if there are 100 namespaces and if there are 10 VMs per namespace, the VM will watch 10,000. So compared to when 1,000 VMs were generated in one single namespace, the number of watches have reduced significantly. So after this simple optimization, we have conducted an experiment. This is the test environment. So we have set up 5 Kubernetes API servers, and we have generated 20,000 controllers and 100,000 custom resources, and we sent revision requests for custom resources to see the API server, the weight on the API server. And this is the result. This is the CPU usage on the API server. So after the initial connection, the CPU usage have soared to 40%. And after we have requested 10 custom resource changes, and we have increased 20 to 20 and to 40. And we have looked at the usage. It does not look like a big figure, but compared to general web servers, these are generation, deletion, and or changes of DB. It is actually quite high pressure work. So according to the test results, the CPU usage was less than 40%. And the API server specification were 2 core 8 gigabyte memories. It was very low, but it showed that it was handled without any difficulty. So I have shown you some of the technical difficulties that we have faced in creating the declarative DBaaS system. Now I would like to talk about how the declarative DBaaS is actually working. So for example, I want to show you how DB is expanded and how the DB parameters are changed and the nodes are replaced and auto healing is done. First is scale out. The user will change the number of VMs from 3 to 4 from the already declared specification, and the DBaaS manager will sense that there is a difference between the actual number of custom resources and will create an additional VM and one more DB instance custom resource. And so the VM operator and DBaaS agent will create VM and DB will be synchronized, and as a result there are 4 DBs, and the user DB service was declared changed. The declaration was changed, and the system is updating the components automatically. And now the next is change of DB parameter. DB parameter change is done similarly. The user changes the parameter and declares the final specifications, and the timeout in this example is changed from 5 seconds to 1 second, and the DBaaS manager senses this change and it is sent to all of the DB instance custom resources, and the DBaaS agent senses the change in the DB instance custom resource and sends the order to the local database. As a result, all the timeout in the DB has been set to 1 second, and the communication among the components is done only through custom resources. This is something to note, and this will loosen the coupling among the component and reduces the reliability among the components. The next function is the maintenance of specific VM or node changes, node replacements when there is a software error. The administrator first needs to delete the VM custom resource that the administrator wants to replace. And in this diagram, there were 3 VM custom resources, but the administrator has deleted 2. The DBaaS manager, so there were 3 VMs, but the administrator senses that there are only 2 VM custom resources, and so a new VM custom resource is generated. And the VM operator senses that the VM custom resource was generated, a new VM is generated, and the DBaaS agent will be sent. And this is the same as before. The DBaaS agent will check the custom resource of DB instance and send the local DB the orders to synchronize the data, and this is how the node is replaced. So in the declarative DBaaS, it tries to satisfy the initially declared specifications. So just for the node replacement, simple deletion is enough. Lastly, I would like to talk about auto healing. This is the scale out of manual node replacement. So when there is a need for node replacement, the administrator does not replace the nodes, but the system can replace the node on its own. So first we need to receive the event called auto healing, and the event can be received in various ways. And particularly, we can monitor the DB status within the node. However, when we have made a mistake in the monitoring of the DB, there can be a large-scale auto-healing leading to a large-scale system fault. But the data because the data that we deal with is a very important DB, we wanted to be more conservative. So if there is a BM replacement in line, we have decided to use the maintenance event. So when the event is sensed, we made it to trigger the VM deletion. So when the VM custom resource is deleted, the ensuing process is the same as the manual node replacement. So the DBaaS agent and DBaaS manager follows through with the next processes. So when the VM maintenance is generated, the node is replaced automatically. So the administrator does not need to do any manual job. So until now, I have talked about how the declarative DBaaS works, and now I would like to wrap up my presentation with a summary. We have set up a declarative DBaaS, and we have made our DB more robust, and we were able to automate lots of more of our operations. And we have used Kubernetes as the framework in order to set up the declarative DBaaS. The system is easy to distribute, and we do not need to manage additional message queue. It's been 10 months since we started this product. We have conducted a lot of design discussions, and we have done POC. And after such processes, we were able to use the declarative DBaaS. And for the other DBs, we're going to apply the same method. We believe that the declarative system is the best way to minimize operating cost, and it will be adopted in various services of line to minimize operating cost and to maximize development efficiency. With this, I would like to finish my presentation. Thank you very much.
Thank you very much, Mr. Han. And now we will proceed with the plus talk. We will invite questions from the participants to have a more in-depth dialogue. Online participants are also welcome to post questions using the question mark on the bottom right corner on your screen. You can post questions there. We have from Yahoo Japan, Kenta Ishida, who will be asking questions. Please go ahead, Mr. Kenta Ishida, and also please introduce yourself. Hello, I'm from Yahoo Japan, and I am in charge of Kubernetes cluster. I am Ishida. Thank you very much. Were there any questions that you had for Mr. Han? First of all, I have a big question for you. You made this configuration into a declarative system. And what was the area that you put your most effort into? Thank you for the question. For a very long time, we worked on the project and we had to think about where to focus our effort. So this is a very good question that you're asking of me. What we concentrated on most was not imperative, but in order to make it declarative, we focused hard. We did make other types of DBaaS, and we used the Kubernetes operating pattern, but they did not act as declarative. Most of the time, the custom resource had been used as a framework, but when it was working, it worked as an imperative. Let's say after the custom resource is created and you create the resource, when the resource is deleted, it should not act. It did not act. It was as if it was imperative. But in this project, we wanted every little bit to be declarative, so that's what we focused on.
Thank you very much. Yes, so declarative was the focus. Yes, thank you very much for the answer. So, declarative. Let me ask you a technical question. So, the managing the parameters as custom resource in the declarative system. So, for instance, for DBs, the static parameters they are not reflected when the server is rebooted. So in that case, in order to apply the changes in the DB, how do you actually work? How do you handle these data? Well, as you have mentioned, according to certain DBs, the parameter is not changed dynamically. So sometimes it does require manual work. But in the declarative DBaaS, we have a rolling restart function. So if we trigger that function, each DB can be restarted. And so my answer would be in that kind of parameter, we can use the rolling feature and we'll be able to apply the changes to all parameters.
Thank you very much. So you have several databases, the clusters are formed, and you load the data one by one, and the parameters are reflected. Yes, that is correct. Thank you very much. This methodology has a similar logic to Kubernetes. And my next question is, you did make the DBaaS declarative, and the operation is using Kubernetes as your framework. And Kubernetes as the control plane, was there anything that you did? Maybe the setting up of the YAML file complex in Yahoo Japan. We do create the YAML file and we move it to the stratification layer. So were there anything that you watched out for in the operation? Yes, as you just said, in order to take the control plane, we had to deploy the YAML file. And you're probably aware, but the common method is customize or Helm. So we did use both in the project. And first of all, we are using Helm. That's because as for customizing the YAML file, you could create and designate many configurations. It does have scalability, but as for our DBaaS control plane, only set parameters are changed and the others stay constant. So functionality-wise, we wanted simpler things, so that's why we used Helm, and that's how we deploy the control plane.
Yes, so comparing customized and Helm, you decided to go with Helm. Okay. Thank you very much for the explanation. So that is it for my questions. Thank you very much.